Yes, welcome to this series of revision. I think we started by looking at September 2021. We had done question 1, quantitative analysis, and therefore in that series we are going to question 2. Question 2 is divided into 2 parts. The first part is theory, which says explain any 4 assumptions underlying game theory. So we'll explain that one, then we move to part B. So we have question 2, assumptions underlying the game theory. So I'm going to list them in highlights, bullets. When you talk about game is a sphere in which we have competitive players. Players here are not purely human beings. Players can be companies, players can be countries, but one thing that they are competitive and having conflicting interest. So one of the assumptions in the game theory is that each player or the number of players is finite. The number of players is finite, meaning they're countable. Even if you talk about football game, we have 11 both sides. That is finite. Even if we talk about indoor games, for example, we have squash and the rest, the number is finite. So we are saying that the number of players is finite, and therefore we can count all of them. Whatever the game, whether it is netball, and even if we have the economic aspect of game theory, competitors, for example, we talk about monopolistic competition, oligopolistic, they are all small firms but countable. We talk about supermarkets. We have media stations, NTV, KTN, Citizen, name them, they are countable. They are all players. And that is one of the assumptions that we can enable, we can count them, they are finite. The other one is when we talk about the game theory is that all players act rationally and intelligently. All players act rationally and intelligently. You see, when you are acting rationally, you are acting for your best benefit. Because if you are in business and I want to sell items, I must be aiming at making maximum profit possible in an acceptable manner. So there's no company, there's no business person that will be going to make losses. That's what we mean that you act rationally and intelligently. You must be quick at thinking and reasoning in whatever you are doing so that whatever your opponent is doing, you can counter. That is what you say, acting rationally and intelligently, that you are able to sustain yourself in that competition. Number 3, we have what we call each player has definite courses of action. Each player has definite course of action. When you talk about course action of action, simply means the strategies. If you are in football, what are your strategies? We have seen coaches trying to make the best of their team, whether you are playing 3-4-4-2, whatever the style, but they are aiming at countering the opponent's strategy. Some can be with 5-2-3-1, so that you have the bulk of your players actually having the bulk in the defense. So definite meaning countable. If I have this formation, I can win. If I have this way, I can win. If I sell certain product with maybe some bonus, I can attract many customers. Those are what we call definite course of action. Course of action are actually, as I've said, strategies, they are alternatives. Last but not least, there is a conflict of interest. A conflict of interest between players. And of course, this one is by definition there, though we can highlight another point, though they are wanted for, which says that the rules of the game are known to players. This one by definition, but the major one, we would put highlights here. The rules of the game are known to all players. So that if you handle the ball, football, it is an offense and you have to be actually punished for it. So we have, that is, conflict of interest is one of the assumptions, but conflict of interest by definition will actually capture the game because you are opponent. Even the army general, they will have to see how to outmaneuver their opponents. They have got conflict of interest. We have the unions and management. They have got a conflict of interest. The union will always have a strategy of strike notice. Management will be coercing them by warning. Those are actually what we call conflict of interest, and they are also cause of action. That is what we have about that part A. Part B, let me read it, and that's where we're going to spend some time. Zachem Limited produces two products, namely Alcon and Xenon. The products pass through three departments, namely assembly, finishing, packaging. There is a maximum of 200 hours in each of the assembly and finishing departments. In addition, a maximum of 400 hours of packaging are available for packaging, Alcon, and Zenith. The table below shows the number of hours required per unit of each product, department, assembly, finishing, hours required per unit of product. Alcon, assembly requires 2, Xenon requires 3. Finishing, that is per unit product. Finishing, assembly requires 4, Xenon assembly, finishing, Alcon requires 4, Xenon requires 2, packaging, Alcon requires 5, and Xenon requires 3. Each unit of Alcon and Xenon gives a profit contribution of shillings 3,000 and 2,000 respectively. Required, formulate a linear programming model to solve this problem. 2 marks. Using the Simplex method, Roman 2, using the Simplex method, solve the linear programming model formulated B, Roman 1, above 14 marks. So let's look at how we look at this 2B. And this 2B, we want to first formulate the LP model. Now, let me say this. LP model requires certain stages to do it. 1, you have to identify decision variables. These are quantities that are actual physical quantities that are competing against the resources. 2, you must be able to define objective function. And 3, you must establish what we call the limitations. Limitation refers to the constraint. So we are given the values requirement per unit. We don't know what they are. The variables are, the quantities are Alcon and Xenon. So we can say, if we are to use Simplex method, we may not require the use of XY, because if there are more than 26 alphabetical letters, then we may not be using that. So we normally use the abbreviation X1, X2, X3, and so on to define this. So I can say, let X1 be the number of units of, call it alcohol, whatever it is, produced, let X2 be the number of units of xenon produced. Now, since we have the so-called profit, economically, every farm must aim to maximize profit. And each unit of alcohol gives 3,000 shillings and xenon 2,000. I'm going to write the summarize because if we put them bit by bit, fine, we'll still have to rewrite it in consolidated form. Therefore, I will put the consolidated form, which is the standard way of writing the linear programming model. This is what we do. We start by the intension, objective function, under what conditions. So we say the LP model is maximize total profit, comma, Z equals 3,000 X1 plus 2,000 X2 for xenon. Under what condition we write subject to? First, this subject to will represent the inequalities. We are told that there is a maximum hours. You see, the usage must not exceed the availability. You can use up to and include what is there, but not beyond. Therefore, the inequalities will represent the constraints or limitation. So we say subject to assembly hours, we are given 200. Finishing hours also given 200. So we shall have this 2x1 plus 3x2 must be less or equal to that 200 assembly hour Next, we are also given assembly and finishing are having 200. That line we have 4x1 plus 2x2 less or equal to 200. Again, finishing hours that are available. We are told packaging is 400, so I'll have here 5x plus 3x2 less or equal to 400. This is packaging hour. Finally, these are physical quantities. We must have x1, x2 greater or equal 0, non-negativity. Constraint. That is for Roman 1. Remember, the objective function comes. What do you intend to do? You maximize profit. So that is what you intend. Z is a combination of the two variables x1, x2. You would still use x and y, but as I said, the standard way is to use x1, x2, because if there are more than 26 alphabetical letters, you are now doomed. You cannot move on. Now, the next thing is using Simplex method, solve the linear programming for me, that one. The first thing, the limitation is inequality. Simplex method uses equations. So the equation to be solved must come from this. The equation to be solved must be coming from inequalities. And therefore, how do we have the equations? What we have is that for this to be equal to this, there must be some part. Therefore, we have to convert the inequalities into equation by adding what we call slack variables. So we say to solve the equations, the model, rewrite as maximize z equals 3000 x1 plus 2000 x2. How many inequalities do we have? We have 3 inequalities. Therefore, we have to have 3 slack variables to bring equations, plus now 0 s1 plus 0 s2 plus 0 s3. Subject to, we have 2x1 plus 3x2 plus s1 must be now 200. Another one, 4x1 plus 2x2 plus the second slack variable must be 200. We have finally 5x1 plus 3x2 plus s3 must be 400. What condition prevails? x1, x2, s1, s2, s3, they are all non-negative. This is the standard form which you now write the so-called LP model to be solved by simplex method. Now, simplex method simply means an iteration in which we continuously work out the values of the so-called basic variables until we obtain what we call optimum solution. What does it mean? We form a table which will contain all the variables, decision variables, and also we have the solutions which are on the right-hand side, and therefore we run this table as in different stages. First and foremost, we start by what we call initial simplex table or tabulae. So we have this. So this is what I'll be having. I have this 3000, 2000, and these are what we call coefficients of the objective function. We always represent them by Cj and write with spacing adequate. There are 3 variables there. I will have what we call decision variable. Then slack variables. And far end, I will have solution quantity. Here, I will also have what I call basic variables. Basic variables, then coefficient of basic variables, coefficient of basic variables. So this would run as follows. Decision variables, I've said, is defined the quantities, economic quantities or physical quantities which are competing among the scarce resources. The quantities here, alcohol as well as xenon. So we can put them as x1, x2, s1, s2, s3. This one I shall have s1, they are introduced here, s3. So to distinguish our variables, we would actually use coloration that would enable us to identify clearly. So we can use the red so that we partition. Can use the red to partition our entries. So when we have used the red to partition our entries, we'll be particular which row or which column we are using. This is the framework. And now what I have here is that the S1, S2, and S3 we call the basic variables. These are quantity which values are either 1 or 0. And in this case, they are starting for slack. They will have to solve for them. What follows here is that the entire table will accommodate what we have here. So the first point is, first equation, we have 2x1, 3, and that. So I write here 2. Next, I write there 3. There is S1 there, its coefficient is 1. There is S2 and the other are not 0, therefore their coefficient are 0. The right hand side is 200. I have that 200. Next, second equation, I have 4. I have 2. I have no S1 is coefficient 0. 1, 0, right hand side 200. Third, I have 5. I have 3. I have 0, 0, 1. Right hand side is 400. So normally, when we talk about the simplex method, we are talking about series of computation, what we call iterations. At every stage, we should be getting what we call better results. And better results will lead us to what we call optimum solution. It shall be testing on various conditions to check whether we have optimum solution. So under this, every point we shall be having the value of z. So zj is what we compute here. This is a value which we need to work out. Zj will stand for contribution. Zj will stand for contribution. Just if I'm going to write it down, then the last part will be what is the opportunity cost for that contribution. So here I have total contribution. This is opportunity cost. And how do we get it? It is the coefficient here minus that value. So I have Cj minus Zj should give us what we call the opportunity cost. Under this column, coefficient of basic variables. Basic variables here, we have S1, S2, that one. Their coefficient from this objective function coefficient, they were 0, 0, 0. Therefore, the starting point, we shall write here 0, 0, another 0. Now, what follows is we make entries underneath each part until even the value for z. The process is we have the product of this column multiplying the various j, that's why we have zj. So first value here is this times that plus this times that plus this times that, which should give us 0. The next would be this times that plus this times that plus this times that, that is still 0. Next, this times that plus this times that plus this times that, still 0. Likewise, that is 0, 0. And the final solution is this times that plus this times that plus that times that. So initial solution for z is 0. What follows is opportunity cost, whereby I have Cj minus Zj. Zj's are here. Cj's are the coefficient above. 3,000 minus 0 is 3,000. 2,000 minus 0 is 2,000. 0 minus 0 is 0. 0 minus 0 is another 0. 0 minus 0 is 0. Now, that is what we call initial simplex tabulae. What follows here is to test whether what we have here is optimal. Now, note, solution is optimal if the final table has Cj minus Zj less or equal to 0. That's the condition. Cj minus Zj less or equal to 0. So, if we inspect here, what follows here is that we don't have optimum solution. Then what do we do? Because these values are non-zeros, these are zeros, they are very big. Then we identify the largest positive value under Cj minus Zj and pick it under what we call pivot column. So we write here solution is not optimal, and we say the largest positive value of Cj minus Zj is 3000. This is under x1. This is under x1. So we write under x1. So we say x1 is entering variable.